I'd like to introduce Dave Raggett. Dave and I go back a long time. I think we actually started working together in the 93, 94 timeframe on what was at the time called HTML math. We then did MathML together, and we did forms together. And the last few years, Dave's been the W3C lead for voice and multimodal. And the thing I like about Dave is that whenever he does new things with the W3C, he usually first builds things. So he builds a few things and then goes around throwing little lighted matchsticks around to see what fires catch. And the thing he's been focusing on the last few months are actually the mobile web, which actually he's been focusing on for quite a while in the context of multimodal, but he is now driving the mobile web activity along with the Ubiquitous Web at the W3C. And his talk, he's going to show you some interesting things he's been building in the context of web applications. He's got speech in his demos. He's got a Loquendo, TTS, and ASR engine, and he just told me that his ASR license is having problems. So you'll have to take his ASR bits on faith, but hopefully the TTS bits will work in this demo. So take it from there. And we are going to be recording this talk, so hold questions for after the video cameras have stopped rolling, since we'll be putting this up on Google Video. Thank you. Go ahead.
Okay, well, very pleased to be here. So how many of you have actually coded HTML tables by hand? Okay, right. If you want to shoot the person who's responsible, that's me.
What a mess.
Okay, so I'm going to do presentations in one of the applications I'll be talking about, which is called HTML Slidey. So sort of a PowerPoint-like clone. And let me just move this back a bit. So basically, I'm going to cover the following areas. There's some new area which I've been sort of promoting and called the Ubiquitous Web, which we'll start with. Then I'll be doing describe work I've been doing over the last few months with Loquendo on speech-enabling web pages using AJAX. And unfortunately, I just discovered, although I gave this demo quite successfully yesterday at the AVL SpeechTech West conference in San Francisco, I think my license must have expired overnight. Because we licensed the software, I think, from January through January, and now it's February. But, so sorry about that. I'll have to give you a canned version of that.
Your computer's clock probably thinks it's in Europe, and maybe it already thinks it's in February. But you could say, well, that's okay.
And then I'll talk a bit about this slide in the idea of web presentations and how that can be expanded onto web meetings. Some ideas for doing that together with audio control through AJAX. And some sort of opportunities, potential opportunities for exploiting this from a business point of view. Okay, so the Oxford English Dictionary says that gives this definition for the ubiquitous as something effectively which is often encountered and seemingly present everywhere. And the term really goes back to Mark Weiser in the very early 90s. And he was working at Xerox PARC, and he started this work up on ubiquitous computing. And so the idea of being able to have all different kinds of devices which are networked. And that's kind of come true to some extent now. Now we have the lot of devices that are networked, but we've yet to really take advantage of that from the point of view of the web. The web has been very ubiquitous, well, at least on the desktop, and to a gradually improving degree in the handset and the phone. But there's many more opportunities for exploiting the kind of perfect devices, getting them to work together, and in combination with network services. So the ubiquitous web seeks to sort of really broaden the capabilities of browsers to enable that, to enable new kinds of web applications, particularly those involving this coordination with other devices and network services. There's some examples here, but I think I'll skip over those. Okay. The main idea behind this is that you really want to be able to identify resources and manage them in the context of an application session. And it could be that these resources are like hardware devices, or it could be that they are services. And so the idea is to provide a framework for exposing device coordination capabilities to the web browser so that you can take advantage of the power of the web and the ease of which people can develop web applications using markup, scripting, style sheets, and images and other resources. So to support this, to get this off the ground, I'm organizing a workshop for W3C, hosted by W3C's offices in Keio University in Tokyo in early March. And so it's got these three main sort of areas we're trying to do. It's to really explore the vision of the web as a distributed applications platform, and to help people to develop applications in this way, to increase the range of such applications. There are many things you can do today, it's just hard work. So we want to be able to extend the range of applications, distribute applications, and reduce the cost of developing and deploying those applications. And another goal of the workshop is to explain the work that's already being done at W3C in this area, in this context. So there's work on essentially standardizing things that have been out there for some while in the web application APIs work, such as XML, HTTP. There's also some work which I started off in the multimodal group a few years back, and on adaptation, and that goes under the name of delivery context interfaces. And then there's the idea of device descriptions, multimodal architecture. These are all sort of pieces of activities going on in different working groups at W3C today, which have an impact on the ubiquitous web. So the workshops are usually there to try and see if it's right, if it's really the community, the timing is right for further standardization work. So in this case, it's to identify and prioritize such areas. And in particular, I think the areas which seem to me at least, and obviously want to ground this through the workshop, is the integration of sessions and device coordination into web applications. And, okay. So a little bit more detail about the current work that's been going on. So the Web APIs working group is part of the rich web client activity. And that's sort of standardizing existing sort of web scripting interfaces, such as the window object and XML HTTP request. Then in the device independence working group, there's this piece of work which I brought there on delivery context interfaces. This work has changed its name over its life as it's moved from one place to another. So it was originally called the system environment, and then the dynamic properties interfaces, and then finally delivery context interfaces. And so the idea is you want to be able to model user preferences, device capabilities, environmental conditions as nodes of a DOM tree, sort of the DOM nodes. So then you can sort of manipulate them in the same way as you manipulate a markup. And so anyway, the idea is then to allow applications to dynamically adapt to those conditions. For example, then if you have a multimodal application and you mute the microphone and mute the output, maybe the application needs to change its behavior accordingly. You also have other kind of conditions which sort of, might occur, like maybe the battery's running low. So maybe you can get a DOM event being thrown from these DOM nodes. So your application then can adapt and do something appropriate to the fact that battery's going to run out and you might lose your work. Or maybe the networks, the network isn't very good. You're in a poor connectivity area, and so you can't really expect to download a video or to view a video. So there's a framework there. It's in kind of a last call working draft. But the next and the real big challenge is to get people to agree to what kinds of properties, what kind of descriptions you want to do. And so the best thing there is to try and build on what agreements there already are. So an example would be properties describing printers and print media, where there are existing industry groups who sort of sweated blood to try and reach agreement on calling A4 A4 and things like that. So that's one piece of the puzzle. And the next piece is how do you couple various components together? And so in the multimodal working group, it's been working on a sort of an architecture, multimodal architecture interfaces for loosely coupling components, user interface components, and an interaction manager by exchanging events. And so that leads on to some work that I've been doing in the ITF with Vlad Sturbu from Nokia Research in Finland. And so what we've been looking at there is we've set up a new working group called the WIDX working group. And the idea is really to support sort of remote user interfaces, where those user interfaces are described in XML, and you can have the application running remotely in the network. That's part of a general theme of moving the applications, making them distributed and moving them into the network. And so in this case, the idea is that the application logic or the interaction manager, whatever the term you use, can send updates, DOM updates, over the network to the UI, and the UI can then send events, DOM events, back. Actually, it's more symmetrical than that, but that's the simplest case. So that group is just it's been launched a few months back, and we've now got the first requirements draft. Let me just make that a bit smaller. So this is a kind of a diagram of a WIDX server and a WIDX renderer. And you can see on the left the server with a kind of a model view controller sort of design. And that's passing events to the WIDX renderer, which could be running remotely in the network. And there can be more than one render or more than one view for each sort of instance of the server. So that might be used to coordinate different devices as part of the same application. So the idea here is to be able to describe updates to the DOM, to the, as XML, and so that you can ship them over the network. So the idea here is, although the group is called WIDX or Widget Exchange Protocol, is actually independent of the markup used for the user interface. So it's a generic mechanism. And so you've got updates which basically involve modifying some part of a DOM tree and identifying which the DOM tree is in the context of a session. And then you have events, sort of a generic way of passing events, so DOM events, back. So again, a sort of XML payload without being specific about just what those events are. So there is a first requirements draft now public and available to comments. And also that when I get back from this trip, I'll be working with Vlad on perhaps coming up with a second version of requirements, we hope. There's a number of different proposals, particularly for the updates. And you need to sort of study those in a bit more detail. And in particular, as, in the OMA, the request of the OMA, the Open Mobile Alliance, and some W3C members, there's some work starting up in the W3C at a task force, which is between the Compound Document Formats Working Group and the SVG Working Group on something called REX. And the idea here is you want to be able to stream updates to, for example, SVG for an animated sort of user interface. So that introduces sort of timing constraints as well. So both the W3C and the ITF are kind of closely coordinating the work on this. So one kind of question really is what's sort of missing or what's improved on. So what technologies are needed for the ubiquitous web? And one of the key things really is sort of managing resources in the context of sessions. Today there are kind of ways of describing sessions, or sort of not very directly in terms of cookies or embedding session information within the URIs. But there's no sort of way of making that explicit. So what the idea here is to be able to perhaps use a URI itself. It's in the spirit of the web architecture to name devices, sessions, and things like that, and services. And so that then allows you, once you can name things using URIs, that means you can then start to express metadata, to provide rich descriptions. It's like to bring the power of the semantic web for describing devices and services and so forth. And that then allows you to start doing discovery of devices and services using the full power of kind of web technology rather than kind of a weaker approach based on things, low-level techniques such as UPN. Another important theme is extending the device capabilities via network resources. And so the example I'm sort of going to try and demo is that of using sort of adding speech capabilities to modern web browsers. But there are other kind of examples will be maybe natural language translation services or geographical location services and many others. Okay, so we want to support applications involving more than one device. So you might have a handset, like a phone and a wall screen, or as a very crude example, you want to use your handset to control the wall screen through the network. It's not necessarily directly connected at all. So we have this, and so in summary, there is this key thing about using URIs for naming things so we can apply metadata. Okay. So there is already quite a few sort of techniques for doing device coordination, but they're not exposed to web pages. If you wanted to try and make use of them, you'd have to write maybe an ActiveX control or something like that and work on some kind of proprietary approach. But there's no sort of general framework for easily doing these kinds of things from within a script in a web page today. So device coordination really has these sort of following sort of basic ideas. First of all, when a service is made available, you want to be able to describe that in some manner and register it so it becomes discoverable. You want to have a mechanism for supporting that discovery, and it may be that it could be kind of on a local device, on the same device, like some years back when you had the cell phones with the separate cameras. When you snap the camera onto the cell phone, now suddenly the device has more capabilities. or it could be that it's a remote on some server somewhere else in the network or on another device like a wall screen. And one of the things which conventional device coordination mechanisms don't do very well on is what happens if these resources are on completely different kinds of networks. Like I've got a cell phone running on a cellular network, I've got a wall screen perhaps running on a wired line or a Wi-Fi network, and that's on an intranet, and the cell phone's on, I don't know, Verizon or something. Okay, so that with the power of the web and the kind of, you can support then much richer discovery, which goes across these different kinds of networks. And having found something, you can then bind that into your session and expose that to like a web page, either through a URI or perhaps an ID ref. So you can actually then name it and maybe send events to it, messages to it. And of course, then there's using a service. So I've talked a bit about this delivery context interfaces through DOM nodes describing things like location information or the battery level or sort of ambient noise levels and so forth. Now, these objects could also have, beyond the framework defined by the DCI itself, they could have additional interfaces which then you can make use of through scripting or through markup. At the end of a session, there has to be some means for relinquishing the service. Sessions might go on for quite a while. They might just be for the duration of a single page or across a few pages, or they might be persistent, in which case you have the concept of joining the session and maybe finding out what the participants in that session are. Anyway, so there's a challenge to figuring out how to exploit existing device coordination frameworks, such as UPnP, web services for devices, sort of a Microsoft idea, Ginny and Salutation and so forth. So an example about this from the DCI work is you could think about location information, where you have you want to get location, perhaps an update every few seconds, or when you move such a distance, or maybe when you come to the next street intersection. And whereas the device itself might have a front end for GPS, but that's sent over the network, that's converted into perhaps latitude and longitude, and then you have some third-party service which converts that back into the information you need. And based on the parameters you provided through the DCI, that then sends you the appropriate updates. The whole point here is to hide the details of the protocols to do that, so that within the web application, it's just a question of perhaps setting some properties for the DCI, and then receiving events as you need. So the actual detailed means for addressing location services and the protocols used to support those are then hidden from the application. Okay, and then there's a speech synthesis stuff here, which I'll go into a little more detail in a moment. The idea of using adding speech services as well, similar way. So I've been doing some work really on trying to figure out how to make it easier for people to explore the addition of combination of speech with conventional web pages. And so one approach to doing speech is to handle the speech modality, or the way you interact with the system, to really describe that in the network. And then obviously you've got a visual web page which is running kind of locally, like in your device in your browser, and to couple those in some manner. And so a number of people have explored that, combining XHTML locally with voice XML on the network, and perhaps using some kind of higher level application sort of flow, for example, using the W3C call control XML markup language. Another approach is to handle the actual speech modality locally within the browser, the visual browser itself. And that still leaves open the choice as to whether the actual speech synthesis, speech recognition is done locally or done in the network. And there's a number of trade-offs between this, so I'll briefly explore that. I've got the next slide covers latency. But quality issues, obviously, if you've got a small device, then trying to provide high-quality concatenative speech synthesis requires quite a lot of resources, memory resources. And again, for speech recognition, the size of the models you have dictates largely the kind of the effectiveness. And so there's obviously memory and there's processing power trade-offs. So that determines the vocabulary. But if you want to do something in the network, again, you have the issue of do you want to pre-produce some of the speech processing in the device, sort of a so-called distributed speech recognition, or do you want to do it all on the network? and what are the costs of doing it remotely. And particularly not just computational or latency costs, but real costs in terms of dollars for network transport. And then the implications for the battery life. So one of the choices I looked at in doing this work was to figure out whether it's worth doing this through like doing a plugin. And last February, or I think February or March, whatever it is, I did a demo of using a binary extension to Firefox for speech synthesis. And that proved fairly brittle across different browsers and contexts. And it looked like it'd be really hard to extend that to support speech recognition, where you want to inject a result back into the browser. So I switched from that to an approach which is basically using sort of a local HTTP server or a speech proxy. Regardless of all these choices, if you're writing applications, you really want to hide the details of whether the speech engine is in the network or local. Maybe you want to use a combination of local speech for simple commands and doing all the complicated recognition in the network. So it would be very desirable to have some kind of JavaScript object or JavaScript interface to support that. Okay, so for latency, if you want to have a spoken command like up, down, or select, and you want to see that change the visual interface, it's really it becomes awkward if that doesn't react very quickly. So if it's much greater than, say, 100 milliseconds or somewhere around the human reaction time, it becomes noticeably sluggish. The other issue is that when you're having a conversation with an application, or as you're in a conversation with another human, that there's these rules or etiquette for how you hand over the dialogue from one person to the next. And so there are sort of latencies involved in that. And so if you introduce too long latencies, again, it feels awkward. You're sort of waiting for the next person to respond. And the final problem is that if you don't actually, somebody's talking too long and you want to interrupt, you want to seize the dialogue, turn back. So that's kind of a barge-in approach. And when you're talking of the other party, and that introduces all sorts of subtleties of getting that to work right. Anyway, I maintain that the network delays aren't as bad as they seem, certainly for the fixed line networks, and the mobile networks is getting better. And that for many cases, users are quite happy to wait a while. And what I was hearing at the conference is that people have brought it down to about a second for network speech in current technology and current networks. And for many cases, that's adequate. But for really smooth flowing dialogues, you'd want it less than that. Okay. So the approach I've taken is really got it to work on Opera, Firefox, and other sort of Gecko browsers, and on Internet Explorer. And so this is using the XML HTTP request mechanism to send a request for initiating speech synthesis or speech recognition, and to have a local HTTP server which then manages the audio stream. So in my case, I'm using the ALSA, the Advanced Linux Sound Architecture. So there's an interface which handles the capturing the speech or the playback of speech appropriately, and using an external interface which makes it importable to other operating systems like Windows. And I mentioned here the idea of using a speech codec. My code doesn't currently do that, but the idea is to explore the use of particularly the ILBC codec, which has a number of valuable properties. And then the remote HTTP server, I've got currently like one for speech recognition, one for speech synthesis, provided speech services. So the general idea for speech recognition, you're just using HTTP, so it's all standard stuff. Using HTTP with the payloads as a MIME, internet media types for the payloads for the audio, for PCM audio, with the ASR and the HTTP request for speech recognition, and then the response is an EMMA, which I'll explain shortly. And then for speech synthesis, you basically send the request either as explicit text or a reference to the speech synthesis markup language file, and as URI, and then you get the audio back as the payload of the response. So this is a kind of illustration at the top here of the kinds of URIs. It's basically obviously local host and some port number in which the proxy is running, and then some parameters, in this case like text equals like good afternoon, or URI equals particular URI for SSML file, the speech synthesis markup language. And similarly for speech recognition, a URI for the grammar file, or the speech recognition grammar specification format developed by W3C. And the idea would be to support additional parameters, as needed, for example, listening on multiple grammars. Whether you want to have more than one result over a period of time. Sometimes you might want to have a sequence of results, depending on what people say, particularly if you have spoken commands, a series of commands. timeout parameters and other ideas. Another problem with this is that if you have really, really large grammars, it takes time to take the grammar file, the XML format, and to compile them into a form which can be used efficiently by the recognizer. So in some cases, you might want to do that by using a preload command earlier on in your application. Okay, so I've got a little sort of I've applied this to a sort of pizza grammar. So in this case, the rule format looks a bit like this is one rule from the grammar file, and this is sort of the top level. And you can see it's really combining two parts. One is the kind of effectively a context-free grammar, and the other is some annotations for computing a semantic result based on recognition. So the semantic result is computed by executing a number of small pieces or small statements of ECMAScript, in a sense. And so that's used currently with voice XML and returns, the result is some sort of ECMAScript object. What I do, though, is actually to generate instead an XML result in Emma, which is the extensible multimodal annotation markup language, which is being developed by the multimodal group W3C. And so here's kind of an example. Here's the grammar in a BNF format. And I would like 4 small cheese pizzas of olives and peppers. So you've got, this is matched against the grammar. And the idea is you get an interpretation back. So you've got the Emma colon interpretation as the outer element. And within that, all the markup in this case is actually application markup defined by the application writer through the way they code their grammar files. There are a number of annotations which you can have, which is like content score, timestamps, and there's many more. Okay. And then you can have more complicated utterances as well. With these kind of interface, rather than asking for one piece of information at a time, it gets a bit sort of unnatural. It's very much nicer if you can ask for multiple pieces of information at a time, give people a more natural interface. So I think that from the AVR Speech Tech West conference in the last few days, that's gaining a lot more credence now, how to do that. People are developing ways of handling that, despite the limitations of the current technology. So in this case, the result, you see there's two pizza elements corresponding to each of the pizzas. And I had hoped to be able to demonstrate that to you live, but unfortunately, I'm somewhat embarrassed of the license running out overnight. But, okay, so having done that, the idea is then you have your speech service in the network, and then people just code away their grammar files and their speech synthesis files. And then how do they describe the behavior? So one way to do that is just to do JavaScript, but that's kind of tedious. And so once you've figured out what particular style you want to do, then obviously you can start to figure out how to express that in markup. And maybe you can code up using some of the work which is being standardized, like the SC-XML or state chart XML, which is being developed in the voice browser group. Or maybe you can roll your own. It doesn't really matter, because you can do this, interpret the markup through JavaScript and do it in a way which is interoperable across all the modern browsers. But the idea is that standards should really follow trying things out in the marketplace, see what things stick, and really be nice to try and encourage more experimentation with multimodal before we get too far with standardization. Okay, so some obviously ways of modeling behavior for that in terms of kind of the hooks which are available to you in HTML pages. So obviously there's events, responding to various events. There's the callbacks from the AJAX, the HTTP responses. There's doing timeouts of various kinds. Timeouts are very critical in conversational interfaces. The dialogue handovers. So you could sort of implement that on top of the hooks you've got, like set timeout. That all gets pretty tedious. That's why you want to do things in terms of markup pretty rapidly. Then there are other kind of things like dialogue goals and history. So there are sort of things you might want to be able to explore. So the idea is we're not going to standardize any of those sort of things very soon. There are efforts to think about the state transition rules, but other kind of things is going to be more experimental for quite a while yet. I'm not suggesting that all behavior should actually be modeled within the web page itself, because the whole theme of the Ubiquitous Web was to move stuff into the network and to give you more control and delivery across a range of devices. But with the combination of this with this remote eventing mechanism, that gives you a great deal of scope. Okay. Now, all this wouldn't work very well if you had no means of tuning it. So a key thing for all these kind of applications is to be able to have a rich logging mechanism, and so that you can then sort of collect lots of data and use that to understand where the applications could do better. And so there, with this particular model, Obviously, the speech server can log the, excuse me, the actual requests, the URIs, but it also log the audio, like WAV files or PCM data. But you need more than that. You need to log the kind of where you are in the dialogue itself. So that has to be somehow within the dialogue engine, so that you get the appropriate AJAX requests going out to add that information into the logs. And this information would be no good unless you could tie it all together. So there has to be some means of perhaps using session identifiers for that to correlate the different parts of the log. Okay, so finishing up on this area, the idea is that rather than have these very sort of simple interfaces which ask you for one thing at a time, you feel you're being dragged around by your nose, you really want to allow users to provide more complex utterances and more of a mixed initiative kind of applications. And this is a desirable, but it does take more work and it requires a more flexible approach for effective dialogues. But the techniques for doing that easily and effectively are now becoming well established. That the exposing speech to web pages in this way through JavaScript gives you the flexibility for trying out the experiments and exploring things, and whilst remaining interoperable across browsers. I think there's some legitimate questions as to the details of this approach, which I'm hoping to follow up in the future. So rather than using a speech proxy server as such, accessed by AJAX, maybe a better approach is to not put the audio into the HTTP request, but to have a separate RTP stream. And so the idea there would be you might have a plugin. You first will make a request to your server, and the back end of Apache or whatever, it figures out, it assigns you a port, an RTP sort of server-side system, and then you ask your plugin to set up that RTP connection appropriately. And thereafter, that then allows you to do all sorts of things like the meetings and teleconference stuff, which I'll come to in a short while. So I think this is something which I'm hoping to explore later. And I think there's an opportunity for sort of discussions about what, if we had a speech object exposed to JavaScript, what should it look like? And is there a chance of actually building any consensus around that? Or maybe something for the future. Okay, so now as a kind of a change of context, I'm now going to talk about some work I've been doing on web presentations. And I'll bring that back to the speech stuff a little bit later. This is something I've done which is sort of an alternative to PowerPoint, partly driven by the fact that many of the W3C staff do presentations, often the presentation looks really bad. They're using some kind of tool which is developed in-house, and it doesn't look very good. And so it seemed to me that the time was ripe, really, was to work on doing some thing based on HTML and JavaScript and CSS. And so I started working on that, and then independently of that, I discovered that other people have been doing this too, like Eric Meyer and Tontek Celik. And so we sort of exchanged some notes, and that's helped sort of lead to sort of rich features. So the basic idea here is to use very simple markup for each slide, and in this case, sort of a div element of classical slide, and then to have it present each of these slides in turn, just by using a bit of JavaScript and a bit of CSS positioning. And you can support a bunch of things like automatic font size adjusting to the window size. You've also got control manually through the keys, bigger and smaller and so forth. This is all works across all pretty much modern browsers. I do have a little bit of problem with Conqueror because it's not quite, it's a bit lacking in some of the DOM features. But on Safari, Opera, Firefox, Internet Explorer, it all works fine. Although I have got some challenges to look forward to, which is making sure it works well with IE7, because I haven't had to lay my hands on that just yet. Hopefully IE7 will actually solve a lot of the real difficult problems, because most of the effort in getting this to work was working around the problems with IE6. And a bunch of features which I'll skip through because I'll show you later. But basically, this is all done as open source under the W3C license. And so, of course, we have like incremental display of bullet points, which is marked up with a class equals incremental. And you can also set this incremental class on a number of different elements, and non-incremental if you want to override this too. Then you can apply this to images. Again, it's like a div, a class equals incremental, with some positioning. So this is an image from the my brain's gone dead. One of these CSS tests. Oh yes, maybe it's at the bottom of the screen. Anyway, there's some sort of test, ACID2. Got it. The ACID2 is a test for how well your browser supports CSS. And this is a bit of a target for some of the browser companies. So I think like Opera, I think, has just got there. I'm not quite sure about the others. Anyway, so the idea, so you can incremental display of images. Then there's the idea of outline lists. So here we have, you add class equals outline. And so this one, you'll see this little plus thing there. So open up or goes away. The middle, the second bullet item here, is sort of grayed out because there is no, there's no what's the word, block level elements within the content of that list. So therefore, it doesn't provide the plus or the minus icon there. So it just shows you, so it's it can't be expanded. So if you click on it, nothing happens. And then obviously you can set, you must sometimes want to have things pre-expanded. So you add class equals expand to that, and then you can hide it and so forth. That's one feature. So some recent additions to this being the table of contents. So that's down here. And then you can go through to each page you want. And the hide and reveal thing was fairly recent. And I'm trying to collect a sort of gallery of things to encourage people to use this. Basically, I'm not a great graphics designer. I did try a little bit, as you can see, with this style here. I was trying to, the digital camera, try and get a few things on here to make it look a little bit better. But I don't claim to be a great graphics designer, so I'm looking for some good graphics designers to help come up with some interesting designs. One of the things I wanted to do, you can use this with SVG. It's best off using SVG Tiny because that's what we get more chance of that being implemented by Firefox, recent versions, Firefox 1.5 or is it Opera 8. But of course, that doesn't work on IE, so you can do a fallback to a sort of an image, a bitmap. But I've been thinking about perhaps using some mechanisms to dynamically convert SVG Tiny into VML to make it work as is with the without the jaggies you get on bitmapped images and scaling, or perhaps via a conversion to Macromedia Flash. And I've mentioned IE 7 tweaks. Maybe some richer styling for incrementally reveal content. I've noticed that Eric Meyer's he's got an approach which shows some of the bullet points before and after, and they highlight or dim. So it's a question of what really people wanted. What I have here is based on sort of asking a number of people what they really wanted. They didn't want fancy transition between slides. They just wanted simple show, incremental reveal, very simple things. All of these fancy effects aren't really used very much. Okay. So one of the things I was hoping to develop was a WYSIWYG editor, because it turns out even with, that many people aren't that comfortable with editing the HTML. And it's often very difficult to edit markup with some WYSIWYG editors. So, if I can read this screenshot. All right. So I hope that's visible. Basically, the idea is to have a very simple and easy to use editor for producing slides, which has something of the look and feel of the PowerPoint, but is actually designed to be easier to use. And so it's got the idea of templates, a number of slide templates, and using the content editable feature. Now that works today. Content editable is provided in IE, but not yet in the other browsers. Firefox supports something called design mode, but it's not very usable. For example, if you're in one of these fields here, like the title field or a description field on this sort of cover slide, that if you press the delete key or the backspace key at the wrong moment, you just lose all your markup. So what you really want to do is to avoid people, destroying their markup. You want to protect people and make it easy for them to use without landing them in it. Right, how to go back. Okay. Then I've been thinking about the idea of being able to support remote meetings, distributed presentations, where you want to drive slidey remotely to somebody, like having a teleconference and somebody's presenting you a series of slides, rather than you constantly trying to tell you move to slide N and the excitement forgetting to tell you to the next slide. The idea is that you could start up the slidey in a way in which it's then using AJAX to poll for requests. So that's straightforward. And the next step beyond that would be to combine this with this RTP sort of plugin, so that then you could get the audio feeds. And I could either be doing that live, or you could be doing it later. And then you might want to move the slides at your own pace, rather than at the pace the presenter originally did it. And in which case that you might want to have it so that when you move backwards and forwards between slides, or you go through the contents to a particular slide, then the audio is synchronized with that. So that's something, again, that should be fairly straightforward to do. Again, using HTTP requests through AJAX to the, like through to Apache and some backend, controlling the RTP stream. Obviously, at some point, it makes sense to think about filters from PowerPoint and OpenOffice, but I think that's going to be quite a long while coming, at least if I'm doing it. OK, so we started thinking a little bit about web meetings. And I'm going to web meetings, then it's a little bit of business stuff, and then I close, so if you bear with me. So we've talked a bit about presenter-driven slide presentations and the possibility of doing that. Then there's the idea of being, for web meetings, you might want to be able to use voice over IP. Within the W3C, we have this teleconference bridge, the sort of ZACAM bridge, and people often use that alongside IRC. And so for IRC is used for a bunch of things, taking the minutes, setting agenda items, queuing people, putting yourself on the queue, whole series of things like that. And so you want to combine like the voice over IP for the delivering the presentations, posing questions, general conferencing, and so forth. And then the other factors like shared minute taking. And OK. So the text-based meeting-related functions, there's a lot, the precedent has been all this work that's gone into the ZACAM stuff of Ralph Swickert at MIT. So by using AJAX to control the RTP resources, that basically means it's very scalable. You could have a whole farm of RTP, of the servers handling the audio and doing the audio mixing, being controlled through front-end through HTTP with some kind of back-end model, perhaps through a SQL database, modeling what resources you're currently using. OK. So I talked a bit about the idea of chatting in the course of a meeting. So it seems to me that despite its current momentum, that Jabber isn't really a long-term solution, and neither are the other kind of more proprietary solutions we see like AOL and MSN and so forth. And we're beginning to see examples like Meebo, who are providing kind of an AJAX sort of a web-based approach. And so that's why I think you can easily integrate this into a kind of a web meeting solution using XML HTTP to support this. The real tricky bits, this is what my colleague Dan Connolly pointed out, is not the kind of the protocol. It's more to do with security policies and mechanisms, like who gets to see when you're online and how do you police that, and what happens if people come into your chat room. How do you control who comes into the chat room and to avoid spamming and so forth. The other issues are that AJAX itself has some security problems, and so that Amit Klein's described this sort of technique for doing referrer spoofing a lot more. And it seems to boil down to the fact that most people writing HTTP servers use scanf. And sort of vaguely, it took me a while to figure this one out. But scanf, when you have sort of spaces effectively between items, it allows any kind of spaces. And then if you put tabs, it confuses the security systems. So you can then sort of have problems with, you can hack all sorts of things. And not all browsers do this. I mean, I think some of these fixes to these problems are being rolled out, but nonetheless, it's a little bit of a problem to be wary of. So I'm kind of winding up here now. It seems to me that there's an opportunity to use some of these techniques. There's business opportunities. So one, obviously, is for meeting services facing consumers and ways to support these. So one way, obviously, is to provide free services, perhaps with some ads. And maybe it's a little bit sensitive in the sort of the privacy issues of spotting text either within the chat streams or within the voice chat, using word spotting on that. But nonetheless, it's a possibility. For today, a lot of companies are using something called WebEx. How many people have heard of WebEx? OK, so it's fairly well known. So when the previous company I was working at, OpenWave, the CEO used it every week to address us. And there was all kind of practical problems with using your telephone to get through and waiting for the operator, problems with the user interface when you're trying to put a question. It would scroll, when a new question came in, it would scroll the thing out of the way. So the CEO was frantically scrambling to find out what the question he was supposed to be responding to. It seems to me that a lot of this stuff can now be integrated through to web browsers, and all we really need is this RTP plugin, and the rest we can handle through just through the existing stuff. And again, the opportunities here are, there's various ways in which you could sort of monetize such services. Obviously, like hosted services, software licensing for other people to do it themselves, supporting some sort of ecosystem of third parties to provide like customization to a particular company's branding or other support they need, and maybe sort of mashups with other kind of services as part of these meeting services. Okay, then again with the notion of these things, integration of other kind of related services. So there's sort of remote storage, archival, and search. I've shown you like the equivalent of PowerPoint or presentations, but there's also documents and spreadsheets. And there we have companies like Rightly and NumSum who are at the moment providing services for web-based documents and spreadsheets. I'm not actually sure spreadsheets is the right thing to promote in the long term. I think there are many things better than, more natural and easier to use than spreadsheets. But nonetheless, you can do that, and NumSum have demonstrated. And anyway, so the list of opportunities goes on here. I won't read out all the details. I have a URI for this, these slides I can provide if you want. Okay, and I think that one of the things of interest to me is sort of the education online learning services. As Rowan mentioned, that we were involved in work on sort of mathematics on the web some years back. And this is one of the things that's been a little bit disappointing, that the web has a lot of potential for educational use, and the current browser developers have been very, I think, remiss on following up on that. Okay, so basically, one concluding remark that the font use in this is actually as unusual for most fonts. It's provided under the GPL, and anyway, by I can't remember. Thukaram Gold Palarau, yes. And if you're using IE, you also get that automatically through the web font mechanism. Okay, so enough of that. What I want to do. So briefly switch back to the demo. Let's see if the TTS license is expired too. Apparently not. Okay, so what I've got here, the screen is divided into the left-hand side has got three consoles or terminals. The top one's running the ASR, and unfortunately it says functionality not completed due to a problem during its execution. License has expired. Damn. I demonstrated this yesterday afternoon at the AVIOS conference, and but anyway, sorry. The next window, the middle window, has is a speech server which is integrated with the Liquendo text-to-speech services, and the bottom window is the actual speech proxy itself. So I have it set up this way so that I can run it without requiring any networking, so it's all using local networking. But clearly, you could put the two, the teach text-to-speech and the other speech recognition servers remotely. Anyway, so the bits I can demonstrate are, for example, speech.
Hello, my name is Simon, and I'm a British voice from Liquendo.
Now, there's a slight gap in the middle of that now starting up because it's clearly, I think, loading some memory, virtual memory, or something is going on there. I think it works better the second time.
Hello, my name is Simon, and I'm a British voice from Liquendo.
So to get these sort of things to work well over average networking conditions require quite a bit of tuning, which I haven't really got down to at this point. The next one is a kind of much older speech synthesis voice called Elizabeth, so it's not as good quality. Well, this is the first one was done using sending a piece of explicit text to the proxy server, and this next one is done by sending a URI to a speech synthesis markup language file. So, okay, what's happening?
Hello, my name is Elizabeth, and I'm a British voice from Liquendo.
Okay, so I think the delay there was caused by loading up that voice font, and you can soon check.
Hello, my name is Elizabeth, and I'm a British voice from Liquendo.
So that's a muddier voice because I think it was a very much older voice, and Liquendo's the new voices are significantly better even than the first one, Simon, you heard. And I can't actually demonstrate the speech recognition right now, curses, but I can show you the general idea. The idea is if you have, say, statements like, I would like 4 small cheese pizzas with mushrooms and olives, what comes back is something like, when I've got back at the bottom here. So you have an interpretation, which will be like M-colon interpretation, actually, with a confidence score, which is one of the annotations in the invitation specification, and then the actual application markup, which is generated by this SISR, or semantic interpretation for speech recognition. And so this Emma allows you to do a bunch of things. N-best lists, lattices, word lattices. N-best list is where, in some cases, you ask the recognizer to send back, say, the top 10 or the top 3 recognition hypotheses. That's not always very useful, so you've got to be careful when you want that. Then there's sometimes you want to see, you've got a long utterance, and maybe one word in the middle you wasn't sure about, the rest were fine. So the overall confidence score isn't very useful in that case. And so then you can get a word lattice back. And so that basically gives like a little graph showing you the words it recognizes, and you can then look at the scores on each of those. I can't actually do that because the Loquendo's speech, the ASR doesn't support that particular feature. But that's something which is within the spirit of is defined within Emma and will be doable with a different speech engine. So with that, I throw the floor open to questions.
Did you have your RSS demo from last year to show off?
Possibly. That might take a while to set up.
Okay. No. If it'll take time, don't worry about it.
So for the speech recognition, so you developed the Firefox extension to record and send back to the server. Am I correct? Or
Sorry, I can't quite hear you.
So for the speech recognition part, so you have developed the Firefox extension to.
No, early last year I did try using a binary extension for Firefox. Binary extensions proved to be very difficult to write. So this what I've got here today works on Internet Explorer, Opera, Firefox, and so forth. So it's basically just using XML HTTP request.
How do you send the audio?
The audio never reaches the browser. It's handled entirely by the proxy. So basically, the proxy server is integrated with in this case, the ALSA speech library for doing speech capture and playback. And I carefully designed the interface for that so that I can replace the ALSA module with a Windows multimedia module, WinMM.dll.
So the proxy server is running on the local.
The proxy server is running locally. Now, the problem with that is that the browsers have a security thing which basically says you can only really talk to XML HTTP to the same domain. On Opera, it's worse. It's got to be the same domain and the same port. So it seems that these rules vary very slightly there from browser to browser. So if you wanted to use this to access a page like it's going here, you'd have to use the proxy server to also load the web page. I think that this is an interesting model. Maybe there's some ways of getting security relaxed for specific uses like this. But the other idea is to use an RTP plugin, in which case you're just using the AJAX to talk to the server you downloaded the web page, which is also managing the speech. But the audio can be routed to wherever you want. So that problem then is avoided. Is that clear?
I don't see the whole pipeline end to end from the microphone to the website.
Well, I'll try and explain in terms of the 3 windows on the left. So if I do the view source.
Well, in terms of the microphone, what is the microphone audio? What receives the?
Okay, so the speech proxy, when it receives a request, an HTTP request from the browser. Okay, so it looks at and sees is it TTS or an ASR request or it's a file request. And if it's an ASR request or speech recognition request, it then starts speech capture.
So why would it get an ASR request? What's making that?
Oh, that's the browser. The buttons I had up here. Okay. I was just going to show you the source to illustrate how this works. All right. So somewhere down here, we have some buttons, in the middle here. And this is all very crude. So on-click equals here text or here SSML or recognize. So there's just some event handlers. And obviously that could be set through scripting rather than through an attribute like this. And then there's the functions themselves a bit higher up. So the recognize, maybe see, I just boost the font size because you can't see that. Is that visible? Yeah. So in this case, here's the function recognize, which is fired off by clicking on that button. And in this case, it's got I've hard-coded the grammar file I want to use within that handler. And it then essentially if it's a Gecko browser, it calls the privilege manager to avoid the pop-up you'd otherwise get, and it then posts off the request to the speech recognizer server. When that server starts up, it sees that it's got a request with an internet MIME type for the PCM stream, and it starts. Then audio is picked off from that.
What collects the PCM stream?
That's the handler for the MIME type, which is actually integrated into the speech recognizer server.
Which is already built into the browser? Or?
No, that's entirely separate. That's running somewhere else in the network. There's several components. The browser,
right.
The proxy server, which is running locally because you want to have your audio locally, presumably. In the network, there is a speech, there's two servers. One is for speech recognition, and one is for speech synthesis.
Okay.
So when you send your HTTP request to your proxy server, it then figures out what to do, which speech service to invoke, and where. It forwards the request, and in the body of the request, it sends the audio stream. And then the speech server gets that request and deals with it accordingly. So I've written both ends. I've written the server. I've got this about 10,000 lines of C code which handles all this. And so effectively, it's basically streaming stuff in and out of ring buffers and doing all sorts of choking or quenching, unquenching, and synchronization, and driven off the poll, making the Linux, the Unix poll function for timing and so forth.
Basically, this proxy actually intercept the HTTP request,
yes,
and they inject the audio stream.
Right. So the HTTP request is directly sent to the proxy, that's in the normal way, and the proxy server then contacts the remote server. So for speech services, it's configured which server to use for recognition and synthesis.
So which functions are you calling on WinMMDLL, and which processes are they being called on?
I don't have WinMM running on here because I'm using Linux here, and I haven't quite figured out how to get that all to work under Wine. So, but basically, I can't remember exactly the details, but I can show you the file.
Okay.
It's basically trying not to do anything terribly difficult. If you're just doing simple playback of PCM or capturing of PCM, you just keep it real simple.
So which process is running that DLL?
That's the proxy server. So with the like, for example, playback there, you set up a callback from the multimedia component, but you can't do anything in the callback apart from send an event. So you then get an event in your event queue. You then pick up that request, and then you deal with it from there. And then you have a small queue of buffers, which you either playing through or capturing through. So it seems better to try to use the things that are widely available than to try to rely on some of the more recent audio interfaces. I really wanted to keep the audio interface very simple so it could be ported across platforms very easily. And similarly for the networking functions. So it's using a poll, POSIX threads, and that's about it. And then for the RTP, the next version using RTP, an RTP plugin, again, just using open source RTP library. And then for the ILBC is a codec, again, it's an open source codec, and the MIME type for that's defined in the RFC, or the ITF. The other things. There's open source acoustic echo cancellation by a guy who works for the German air traffic control organization. And it seems to work quite well, actually. But to make those sort of things work well with speech recognition, there are subtleties. If you start using codecs and you start using acoustic echo cancellation, things can start to go slightly awry. And again, there are ways of mitigating that. So anyway, so the broader theme there is really the Ubiquitous Web, which is the coordination across devices and resources, and how do you expose that to web applications. And the speech is just an illustration of the kind of service you might be able to add in this way. Okay. Any more questions, or are we all done? We're done.
Well, we're done. Thank you, Dave.